In this lesson, we're going to look at solving inequalities. And you may have seen some of this before. Hopefully you have. And you'll recognize that it's almost the same as solving equations. And we'll see shortly the one twist that's a little bit different. So when we're solving an inequality, we follow much the same steps. We want to isolate the variable on one side of the inequality sign, get the numbers on the other side so that we know what the possible value or values for x or whatever the variable is. So I'm going to do this method of putting our rough work on the right side. So I want to isolate that 2x, so I'll subtract 5 from both sides of the inequality. So I'll have 6 on this side and 2x on this side, and then I'll divide both sides by 2 to get 1x. So x is less than or equal to 3. Okay, so the way to check your answers with an inequality is to choose some value that's true in this statement. So if we think of x being less than or equal to 3, a nice value to check would be x equals 0. Okay, so we just substitute that into the original inequality. So we'd have 5 plus 2x, so 2 times 0 is less than or equal to 11. So we end up with 5 is less than or equal to 11, which is true. Okay, so then we could choose some value that's not in this interval of x less than or equal to 3. So we can choose some value that's greater than 3, like 4. So let's just test x equals 4. And so we'll have 5 plus 2 times 4 is less than or equal to 11. And we end up with 13 is less than or equal to 11, which is false. So the answer is correct. The number that was within this variable was true, or within this interval, sorry, was true. The number that was outside that interval was false. So this is x less than or equal to 3. We could be pretty confident that that's the correct answer. There's 3 ways that we can represent our answers besides the one that we just did. We could do it on a number line. So we could set up a number line with 0 and 1, 2, 3, 4, and -1, -2, -3, and -4. And we said x is less than or equal to 3, so we can do that on the number line. Square bracket because it was allowed to be equal to, and then an arrow showing that it goes off to the left to be less than or equal to 3. The next method would be to use our set builder notation. We can say x is all real numbers such that x is less than or equal to 3. Or we could use our interval notation where we're going from -infinity to 3 with a square bracket on the 3 because it can be equal to 3. So let's take a look at another example of solving an inequality. I have -3x is greater than 9. If I want to isolate that x, I could divide both sides by -3, and I would end up with x is greater than -3. Is this correct? Let's test using those intervals before. So x greater than -3, well 0 is greater than -3, so let's try x equals 0. So we have -3 times 0 is greater than 9. We end up with 0 greater than 9, which is false. So that doesn't make sense because we've said here that x is greater than -3. Okay, let's try something that's less than -3. So let's try x equals -5. If I plug that into the original, I'll get -3 times -5 is greater than 9. And so that's -3 times -5 is +15 is greater than 9, which is true. Okay, so we need to do something different here. And this is the one rule that's different from solving equations. If you multiply or divide both sides of the equation by a negative number, you need to reverse the sign. So in this case above, we actually have to give the answer as x is less than -3. x is less than negative 3. And you could test more values of numbers less than negative 3, and when you multiply them, you'll see that you end up with numbers that are greater than 9, so that it is a true equation, or inequality rather. Okay, so let's take a look at this next example. 3 minus 2x, there we go. 3 minus 2x is less than or equal to 11. We want to isolate that 2x term, so we'll subtract 3 from both sides. So we have 8 and negative 2x. To get 1x, we need to divide both sides by negative 2. So we'll switch the sign. And so we'll have x is greater than or equal to negative 4. And I forgot to switch that sign. So x is greater than or equal to negative 4. If there's an equals with it, keep the equals with it. Just do the mirror image sign. Okay? So let's check this. If x is greater than or equal to negative 4, we could try x equals 0 again. I really like using 0 because it's so quick to do the math when we're testing that value. So then I have 3 minus 2 times 0 is less than or equal to 11. So I end up with 3 less than or equal to 11. That's true, so we're good. Okay, so our answer is any number greater than negative 4 will make that correct. So again, let's try expressing that answer in different ways. We can use our set builder notation. We can say x is all real numbers such that x is greater than or equal to negative 4. We could use our interval notation, and we'll use a square bracket this time for that. And we'll go from negative 4 to positive infinity. Always round brackets on the infinity. Or we could use our number line and express it that way. There's negative 4, and if x is greater than or equal to negative 4, we're going to have a square bracket at the negative 4 and an arrow going to the right to infinity. Okay? All right, let's look at a question that involves a few more steps. Question 4 here, I've got some brackets to work through, so always simplify through the brackets first. So I've got 2x plus 8 is greater than 2x plus 3. Let's subtract the 2x from the right side here. So I have all my x's on the left. So subtract 2x. So I end up with 8 is greater than 3. Notice that there was a 2x on both sides. So when I subtracted 2x, it was eliminated. So if the variable is eliminated, and you end up with a true statement, and in this case it's true, 8 is greater than 3 no matter what, then really the solution is all possible numbers. So all possible values of x could be inserted into our original inequality here, and we'd end up with something true. So the solution is negative infinity to infinity, or we could write it as x is all real numbers. Okay? And it's really important that when you have a solution like this, that you do write it in one of these two methods, saying that all values of x are included in the solution. Okay, so let's take a look at another question. Number 5 here, I've got x plus 7 is less than or equal to x minus 2. Let's subtract x from both sides again. And I end up with 7 is less than or equal to negative 2. Notice that this is not a true statement. 7 is not less than negative 2. Okay, so if the variable is eliminated and the remaining statement is false, then the solution is the null set, the empty set. No value of x is going to make that original inequality true. Okay, and again, very important that you recognize that this is false. 7 is never less than or equal to negative 2, so this is the solution, the null set. You could also write it as an empty set of brackets, but it's easier just to write the 0 with a line through it. All right, let's take a look at this next question. And again, there's some brackets to multiply through here. Let's work through those steps carefully. And there's just a little something I want to show you at the end of this one. So when I multiply through the brackets, I'll get negative 4x minus 8 is greater than 3x plus 20. So let's add 4x to both sides. And that way I'm getting rid of that negative 4x there. So then I'll have negative 8 is greater than 7x plus 20. Let's subtract 20 from both sides to get the x's by themselves. So I'm left with 7x here, and negative 8 minus 20 will be negative 28. So now I want 1x, so divide both sides by 7. And I've got x there and a negative 4. If your solution looks like this, don't put a box around it because you're not finished. Really, you want to write that in proper form, which would be x is less than negative 4. Instead of negative 4 being greater than negative x, okay, don't write a box around this, okay? Put it in the correct format first. Or you could write this as well as the interval x is less than negative 4, so negative infinity to negative 4. Okay? So that's just a little piece of formatting or how to write things carefully. I want to do one more example with you, and that's when we're solving a compound inequality. A compound inequality has two inequality symbols in it. And you have seen these before when we've said that x is an interval with um, a, a boundary on the left and a boundary on the right. And so this is one of those cases. The trick here is isolate x in the middle section, okay? So I have x already in the middle section of this one. So let's subtract 1 from all three pieces. So if I subtract 1 from the left, I'm at negative 4. Is less than, if I subtract 1 from here, I end up with 2x. And if I subtract 1 from the 3, I've got 2. And then let's just divide every term by 2. So I'll have negative 2 is less than x, which is less than or equal to 1. And so that's the interval, negative 2 to 1, round bracket on the negative 2, square bracket on the 1. So now you're ready to do the first section of questions in your textbook. And that's the end of this little lesson.